Hello and welcome back to Electroculture. This is actually part two of the first short that I put up today regarding electrostatic generation of power. And I want to, in detail on this one, discuss the theory and the first two experiments I did in the middle of the desert, the high desert out there in the West Mojave by El Mirage Dry Lake Bed. And I want to talk about the how I came about this discovery. It was sheerly by accident. I was studying Lenz's law and dealing with counter-opposing magnetic forces. I was trying to levitate a small alien spaceship out of this landscape, like a desert that I was making. And in result, I ended up discovering a fascinating aspect of physics, and was able to produce an enormous amount of energy with no heat dissipation, with two tiny inner and outer coil hole saw designs. So first of all, this is the schematic. And you can see you have a 24 volt plus DC. I used a variable power supply, constant current, constant voltage power supply. There was a plus and there was a minus, or the ground. And L1 was the inner coil, separated by an alternating current capacitor, a 0.47 microfarad, 600 volt AC paper type capacitor. Nothing special. And that was the inner hole saw casing, which was steel, thus the two ferrous line indications there. Then the outer coil, the inner coil was a 1 5/8 inch inner diameter Milwaukee hole saw, steel hardened carbide tips, and the outer one was a 2.5 inch steel Milwaukee hole saw, kind of indicative of this drawing right here. So you can see the 2.5 inches, and then the 1 5/8 inch, and then of course the bottom is just where the mandrel would normally screw in. It holds the drill bit, which I did not use for this experiment. This experiment was recorded by myself and my wife, witnessed it as well. I'm going to try and get those recordings from her. Haven't seen her in a minute or two, so we'll get those going and show proof of what actually happened. So I want to discuss the theory, and this deals with instantaneous voltage changes causing electrostatic forces. This is basically a non-electromagnetic effect, what was witnessed. So it says the instantaneous voltage rise applied to the 24 volt input leads causes an immediate bunching effect of charged particle carriers, or point charges. This bunching occurs at the AC capacitor. Keep in mind, this is not a DC or electrolytic type capacitor. This is an alternating current capacitor only, which blocks DC and allows AC currents to pass. Yet once the backup of charged particles is great enough, the AC cap is overcome. The particles surge out through L2 like a dam that just broke. Actually, the potential difference between L1 and L2 becomes so great that an induced back current develops and surges backwards in L2 coil, caused by the back EMF generated between L1 and L2. Master IVO has a great series of videos discussing bifailure and pancake coils and this bunching effect. He has a great description of Nikola Tesla's actual words from his original patents, and I thought I would just drop his name because he's helped me out quite a bit understanding what is going on. And this is the one of the pancake coils that I used in the preliminary electrostatic generation video. It was just used surely this is about a 5 millihenry with a circular magnetron magnet in there, and these are both capacitive and inductive. So I have about 5 nanohenry, 5 nanohenry, and 5 millihenry and 5 nano farad capacitance within this. So it's both an inductor and a capacitor. That's what Nikola Tesla liked about these type of coils. They're very efficient and versatile. So going back to the explanation, so this massive inrush of particles and electrons that carry these charged particles translate to a strong mechanical torquing motion that will cause the cylindrical steel coil housings to tumble in the direction of the cutting teeth. So as you see on the coil on the top, you have these torqued and directional teeth that are hardened carbide, which definitely helps in the inductance of the overall design of the coil, and adds an incredible amount of mass to the counter-opposing magnetic fields. So let's see here. The cylindrical, sorry about the handwriting, my computer's broken right now, and I'm on a shoestring budget to do all this stuff. So getting back to this, so it causes the hole saw to literally tumble and turn off the desk, tumbling in the air, and hovers mid-span in the air. It did in the steel storage container that I was in. I was in a 40-foot steel storage container, and it stayed there for 2 full days, not emitting any kind of heat dissipation, actually generating its own light. It's just fascinating. But it even separated itself from the DC bias supply, the tether leads, from a 24-volt constant voltage, constant current power supply. My first 2 experiments were conducted in 40-foot steel storage containers out in the high desert. Keep in mind that high winds are prevalent in the high desert. Constantly have high winds, which helped aid with large electrostatic charges building up on the outside of the Corbin steel. Actually had a huge buildup of electrostatic charges, I said, on the outside of my steel studded Faraday cage. And I say it's a Faraday cage because I had still studied the inside of it. A true Faraday cage has an inner and an outer steel wall that gives full containment. The only thing that would have made it a pseudo Faraday cage was the steel security screen door that was located in the very entrance of the 40-foot long container. So the coil hovered for 2 days in the middle of the container. I couldn't move the coil body from midair. No heat dissipation, and complete tether separation from the DC power supply had occurred. The power supply only surged at about 35 milliamps and then took off, tumbling into midair. As soon as I surged the 24-volt supply, 0 to 24 volt, it sort of rocked on the workbench at first, and I thought, my God, what was that? And I said, hang on, babe, and get ready to, maybe you're going to see a spark. And I hit it again, and the thing just took off midair. I tried pulling it out of the mid-air where it hovered, and I couldn't budge it from the air. It was just the most fascinating thing I've ever seen. And you could see the etheric currents flowing in and out of this inner and outer cased hole saw assembly that held and housed my counter opposing magnetic filled coil windings. Light was generated. It was a soft pink hue. I could see the etheric currents entering and exiting the 2 coil from the top and the bottom where the teeth are, then going in from the bottom where the mandrel would screw down in. Had an effervescent feeling to it, much like Tesla explained. The initial shock wave was one that I felt. It was a stinging sensation in my body. It was the only pain I really felt, which wasn't really all that bad at all. And even the temperature within the container regulated to a constant 75 degrees Fahrenheit, which out in the desert, it's extremely cold or it's extremely hot. And here was an outline of the container itself. I had grounds on all 4 sides You can see earth grounds. I had grounding rods placed in there. And this little, this was the front door, the screen door. So this was kind of like why I say it's a pseudo Faraday cage, because this door was open, this door was closed, and it has hole perforations in there. So some magnetic radiation could escape, but not very much. It had a very small leakage effect to it, if anything. And this was the workbench where I'd set the 24-volt supply. And when I surged it, it torqued in the direction of the teeth of the hole saw. It tumbled up into the air, kind of vortices around, and hovered there for 47 straight hours, not budging. I put everything I had into it, tried to move it from midair. It wouldn't move. It was almost like a strong force on a macro level. This was witnessed by my wife, Katya, and I have videos. I just have to get with her to locate these things. There were thousands of videos we made on these experiments. The outer steel was a Corbin type steel. It was weatherized steel. I had a 1/2-inch styrofoam 4x8 sheets and a 1/2-inch plywood on the outer coating of this container number 1. And you can kind of see the hole saw where the currents were going in and out of this like a circular. It was just the most fat. You could see the currents itself. It almost showed up like green and blue and pink speckles of light. I've never seen anything like it. It controlled the lighting. It had a nice soft hue, a pink hue inside the container. And like I said, I felt zero pain. And I had been electrocuted on a job site prior to this, which was really a blessing from my higher power that this even happened. Mother Earth produces, as Coulomb said, for every cubic meter of space or volume, all the way up to maybe 250,000 feet, there exist 400,000 coulombs per cubic meter, and that translates to about 100 volts of limitless power. I'm not saying there's free energy, but there's certainly how do you extract that energy in an efficient way to power an entire community, and this is how I would propose doing it. Also, keep in mind I had wind generators going on out there, and I had a shroud over the wind generators that was coupled. The charged particles were coupled back from these wind generators, little 12-volt Walmart wind generators, and the charged particles were coupled back with PVC pipe to two 250-gallon saltwater capacitors that I mixed in with, made some graphene collation. I added some manganese, some barium, BaSiO3 compound, and a ferrous compound to it, as well as the graphene and some silver oxide. So I had very, very efficient capacitors. They were slowly drain off quite a bit of current for quite a while. But the interesting thing here is that this had nothing to do with those capacitors, and it had nothing to do with the wind generators. Although the high winds cutting across on the outside or on the top of this, I had solar panels laid all the way across this, probably contributed something in large part to the amount of energy that this coil ended up translating and pulling from this type of energy. Also out in the desert, keep in mind they have a lot of the HARP testing programs, a lot of the military jets with the terrain following radars and so forth. A lot of extra energy out there. But last night's demonstration on just making an efficient electrostatic generator, you could kind of see the design. I'm going to go over it with you guys here in just a little bit. But I don't want to make too long of a video here, but I really wanted to get this out there. So I used 23 gauge twisted pair, CMR rated, which is PVC coated, jacketed, unshielded twisted pair, UTP, unshielded twisted pair type cable. These are the kind found in patch cords. This is equivalent to a category 6 in data terms, data cabling. This is a type patch cord used for data Ethernet patching. Keep in mind, it needs to be stranded wire, not solid. You want the parasitic capacitance, the added parasitic capacitance is very important because it adds a high frequency component to it that builds up within the coil itself. Every time a wire crosses another wire, you have one wire crossing another inside stranded wire, that forms a small capacitor right there. And this would be the length of that wire would be the resistance, which this is the schematic for unshielded twisted pair. You've got the one pair here. You've got the length of it represents the resistance, the DC resistance. Every time the coils cross each other, the twisted pair forms a capacitor plate. So you have the two insulations and then the copper wire on the inside. So it's dielectric, two copper plates. Then you have the inductor where they cross and they rotate around. And of course, more twist represented by another capacitor. These really represent parasitic capacitance. But the cool thing about unshielded twisted pair is that you have capacitive reactance, which is inversely proportional to its sums, and inductive reactance, which is directly proportional. So in other words, if frequency increases on this side of the equation, or equal sign, then inductive reactance increases on this side. Versus the reciprocal, frequency increases on this side, capacitive reactance decreases. So it forms a perfect balance of impedance, overall impedance, line impedance on the circuit. L1 and L2 also in the design, they need to be as close as you can to get the same mass as each other's windings for the inner and outer. Not necessarily the same length, but the same mass, because keep in mind, twisted pair itself, this is my workshop, is one of my bedrooms here that my friend is letting me use, my friend Ponce. But look at how the twist rates are varied between the different colors, the white blue, white orange, white green, and white brown pairs. So there's variance of impedance and variance of inductive and capacitive reactance changes. So what I also did was halfway through, so this is going to be the new design here. I'm going to use a stainless steel magnetized bolt. That looks like about a 3/8 inch or 5/16 inch bolt that I cut down to match the stainless steel cylindrical shape. This is very important. The cylinder is what makes this magic happen on this coil. Counter-rotating magnetic fields creating Lenz's law effect, which generates back EMF for a moving magnetic field going through a stationary field. Like this would be the stationary coil inside here, and one of L1 will generate here, will generate the magnetic field. L2 is wound in the opposite direction, so this one's wound from top to bottom. L2, the outer ring here, I don't have yet, but it'll be from bottom to top, and it'll be, instead of counterclockwise, it'll be in the clockwise direction. So you have north and south poles opposing each other, in and out. So you have to think forward, backward, and reverse, if that makes any sense. So I kind of drew a little schematic here. There's the bolt on the inner coil. There's the direction of the teeth. I am going to cut in some teeth to help with aid in mechanical torque. And the takeoff of this coil literally takes off. Last night's demonstration was only 0 to 12 volts, and it was a constant 12 volts. There was no variance. It was no variable supply. It was just a 12 volt AC adapter at 10 amps, switching power supply. So again, it says top wound down for coil clockwise, and then of course the L2 would be on the outside of this, and it would be wound from bottom up in the counterclockwise direction. So let's see. I was taking some notes today on Gauss's law and Maxwell's four equations, which pretty much sum up what is going on with electrostatics. And you can see here is the change in electromotive force with the vector is equal to 4 pi p. The second one is the change in the magnetic field strength is equal to 4 pi or epsilon 0. It's commonly 1 over 4 pi. Epsilon 0 is usually always they're talking about the permittivity of free space, and we can get into that later on in the other videos. But you can kind of see these are the Maxwell equations that led us to allow for these charged particles to build up. Now imagine this is kind of a sloppy representation drawing. I was in a hurry. Imagine if you wanted to levitate a sphere with this upward vector here sitting on the top of this. You have a large outer. It's kind of raised up, elevated from the inner winding. And Professor Eric, oh gosh, I can never remember his last name. Lateworth, I believe, from England or from Cambridge, makes a great video on this levitation process and Lenz's law. So I've got some equations, some math written down here. You have the electromotive force, how much force is going to be required to move said charged particle Q1 to infinity, and then also from infinity back down to Q1. But the derivative of these things, because you're dealing with electrostatics, you can just eliminate the di dt derivative. If you guys know anything about calculus, you're basically everything on electrostatics is linear. It's a linear calculation, so it really makes it easier to understand. And you're dealing with not only the field strength of the magnet B, but also the change in the flux density. This is Q, and then you're dealing with the volume here, volume times the vector of the radius. So distance r that it has to travel. Sorry about that. So this is what we've got going on, and again, this is what I'm going to do. And just refer to last night's video as an instructional, kind of like how to generate electrostatics efficiently without really having a Van de Graaff machine or a Wanghurst generator or anything like that. And this twisted pair, when you wrap it tightly, neat, organized, tight winds on the inner coil. I know it's just a mess right here, but it's what you get when you strip a patch cord. I think this is like a 10-foot long patch cord. But I'm going to also transition from the blue to the orange pair and then the green to the brown halfway through the mass of the coil calculation, because that also aids in bunching and velocity changes in the flow of the electrons. And it's really not the electrons that are flowing it so much as it is the electrons that are enabling or pushing the charged particles on the outside of the jacket, called skin effect, because of the high frequency discharges of the parasitic capacitance of the stranded wire. This is really the key secret. It needs to be stranded, remember that. And if you can get silver, it's even better. If you can coat your insulation in a graphene, even better yet, or a carbon 60 maybe. You want to add inductance to this thing. You want to add conductivity and inductance to it, making it very, very, very permeable. You want a high permeability on your circuit. You want a high Q output. And all this stuff is kind of going back to, I'm looking at different types of energy right here, which I've started, you can see the mess over here, but got my arc gap, high voltage transformers and stuff, but spinning magnet down there and so forth. But here you can see, instead of having, if the power grid went down, what would you do, So I proposed a one-wire electricity, kind of using Nikola Tesla's ideas, but I modified it significantly by inflating a balloon of helium and raising that up and bringing up from the ground or from the atmospheric electricity. For every meter, you get about 100 volts. So that's enormous. Like I said, Coulomb's law. You're going to get 400,000 coulombs per cubic meter. But you've got, if you took just taser guts, you could, pulse that into a spark gap that would dump off into a capacitor circuit, a MOSFET pre-driver, a driver. Then you have your bifilar, or you have a flat pancake magnetic component coil, which would be stranded heavy gauge, probably about a 14 gauge. and I'll get into this more. I thought Master Evo or IVO really nailed it on this. He talks about the resonant calculation of these coils, and that's a real secret. But what you do is at the outlet, you would just have the one wire, and you plug it into the ground, and you'd have the neutral and the load, and then of course the ground, and it'll power anything from LEDs, pulsing DC, or you could use AC. And the cool part about that is you can't get electrocuted with this. It's pulsing 5,000 to 10,000 volts on the ground. You can't get electrocuted, and it's just a wonderful new technology that is going to be being brought out. And also you can charge batteries off of cell phone or cell phones off of your AP wireless antenna systems. So this is what electroculture is all about. Aside from Elon Musk has a competition called X-Capture. It's about who can absorb 1,000 metric tons of carbon dioxide per year and store it in solid hydrogen form. So these are very important things for the planet to become green, making kelp grow faster. Kelp produces about 80% of the world's oxygen. All this high voltage stuff makes plants grow faster, and that is really what electroculture is about. So thank you so much for this video, and I can't wait to finish prototype number 2.